Good morning, listeners, and welcome to today's class. Today, we will be looking at the two concepts measures of central tendency and measures of dispersion. Of course, we can't talk about measures of central tendency and dispersion without talking about data. And of course, when we talk about data, it is important that we talk about types of data, sources of data, and method of data collection. So to begin this class, I think it is necessary that we look at some basic concepts in statistics, beginning from statistics itself. So the question is, what is statistics? What is what? Statistics. Statistics. Statistics, of course, is defined as the act and science of making generalization on the whole from the information contained in the parts. A method, an act, and science of making a generalization on the whole from the information contained in the parts. So there are two key words here raised here. And the key words are one, acts and science. We have acts and science. Acts and science. Statistics is the act and science of making a generalization on the whole from the information contained in the parts. There are equally two basic words that I mentioned there, and those words are whole and the parts. So I have whole and parts. In the context of this definition, of course, what we mean by whole is population. Is what? Population. And what we mean by part is a sample. Therefore, one can say that statistics is the act and science of making a generalization on the population from the information contained in the sample. This is what a statistics is. So the question is, how is statistics an act? And how is statistics what a science? Statistics is an act because it involves some level of creativity of presenting the data in a way and manner that the information contained in the data can easily be understood or comprehended by the what? By the reader. So it involves that creativity, that idea of presenting your data in a way and manner that the information contained in that data can easily be understood by the what? By the reader. It equally involves some level of creativity of making choice from competing statistical methods that is suitable for a particular research. And of course, when we talk about creativity, it is a thing of what? Of acts. So that's why we say that statistics is what? Is an act, because it involves that level of creativity of presenting the information, which we call data here, in a way and manner that can easily be understood by the reader. It equally involves the creativity of the act of making choice between competing statistical methods that are most suitable for a particular research. That is what we call that statistics is what? Is an act. And of course, statistics is a science because it involves developing the method itself and validating the ability of this method to be able to make a conclusion about a particular research topic or research objective. So that, of course, what we mean by saying that statistics is what? Is a science. What then becomes the importance of statistics? What are the relevance of statistics? Talking about importance of statistics, permit me to clear. Talking about importance of what? Of statistics. Importance of statistics. of statistics. Of course, even from the definition of the statistics that we just looked at, one can say that statistics helps researchers to present their data in a most informed way, or present their data in a way and manner that can easily be understood by their what? By the readers. That is number one importance of what? Of statistics. And of course, based on the definition still, we did say that statistics helps is an art and science that helps to make a generalization on the whole from what? A part. So equally, statistics help researchers to make conclusion, generalization, inference about the population from the information contained in the sample. That is number two importance of what? Of statistics. Statistics equally helps us now to understand the fluctuations that exist in what? In the data, be able to isolate it and study the underground process generating the what? The data. This is also a relevance of what? Of statistics. There are too many reasons or importance of what? Of statistics. And equally coming back to that definition where we made mention of a population and a sample. It is better we understand what we mean by population and understand what we mean by sample. So the thing is, what is a population? What is what? A sample. What is population? And then what is what? A sample. Of course, when we talk about the population, we talk about the totality of items, persons, objects, animals that are being etc. that are being considered for a particular research. That is what we call population. You might come to a particular university and your interest is to conduct research on the intelligent quotients of what? Of the students. You are looking for the entire population of that university as being your what? Your population. Totality of persons, items, objects, animals that are under consideration for a particular research. That's what we refer to be as a population. But there is a serious problem behind this population because it is not always easy to get all the units of a population needed for what? For that particular research. Because it is always impossible assessing the totality of units in the population, people always resort to taking sample. So sample is a subset of this population or a fraction of this population that is collected for the purpose of what? A research. That is what we call population and what we call sample. Of course, they have their merits and of course their demerits. So this is actually what we call statistics, being an act and science of making a generalization on the whole from a part. What is a whole? Population. What is a part? Sample. Therefore, statistics is the act and science of making a generalization on the population from the information contained in the what? In the sample. How is statistics an act? It's an act because it involves creativity of presenting your data in a way and manner that the information contained in the data can be understood by what? By your reader. It's also an act because it involves creativity of making choice between competing statistical methods suitable for a particular what? Research. Why statistics is what is a science? Because it involves developing these methods himself and validating the ability of this method to be able to make what? A conclusion about a particular topic or idea in a research. What is then a population? Totality of items or units that are under consideration for a particular research. Why then do we have to leave it and go over to the sample? Because getting all the units in this population is always very difficult. Therefore, we resort to taking what? Sample. And sample is just a subset or a fraction of what? Of a population taken for the purpose of what? A research. Therefore, what then do we talk about? What types of what? Data. Because we say, for us to talk about measure of central tendency, we must talk about what? Data. And when we talk about data, it is equally good that we talk about types of what? Data, source of what? Data, and method of data collection. So permit me to clean here. So I talk about what we call types of data. Types of data. Talk about what we call sources of data. Talk about what we call method of data collection. Method of data collection. Of course, the different types of data we have are classified based on some criteria. The different types of data that we have, they are classified based on certain criteria. And those criteria are, the number one criteria there is what we call based on time dimension. Based on time dimension. Time dimension. Classification of what? Of types of data based on time dimension. We equally have what we call degree of aggregation. Degree of aggregation. Aggregation. And then we have what we call level of measurability. Level of measurability. So before one can talk about types of data, one should be bearing in mind these parameters, or this what we call criteria. Then under this time dimension, we are going to talk about three things there. What are those three things we are going to talk there, being the types of what data? We are going to talk about what we call cross-sectional data. Cross-sectional data. Cross-sectional data. We are going to talk about what we call time series data. Time series data. We are equally going to talk about what we call panel data. Panel data. We are going to discuss, because these three kinds of data exist under time dimension. Then we come over to what we call degree of aggregation. In degree of aggregation, we are going to look at two things called micro data and macro data. Micro data and what we call macro data. Macro data. And then under the level of measurability, we are equally going to talk about two kinds of what data. And those two kinds of data we are going to talk there is what we call qualitative and quantitative data. Qualitative and quantitative data. Quantitative data. So these are the different kinds of types of data we have existing under these criteria. So we begin by what we call cross-sectional data. A data is cross-sectional when that data is a measurement coming from different or from many experimental what units on different subject matters collected at a particular time. It involves measurements coming from many experimental units on different subject matters collected at a particular time. For instance, under this cross-sectional data, that you come and you want to look at the age distribution of students of a particular school. You have arrived at this school on a particular day and at a particular time. And you are led to a class, and all the students in that particular class, you go ahead there to measure their height, measure their weight, collect their age, and the rest of them. These things you are doing is on a particular time. So you are collecting these measurements from many experimental units, which stand to be what students, and on many subject matters, which stands on what? On their height, on their age, on their what? Weight, and so many other parameters you can be considering at a particular time. That is what we call cross-sectional data. In that cross-sectional data, you might have something like this. Permit me to clean it up and be able to give you some emphasis on that. In that cross-sectional data, you might have something like this. You might have something like this. That you now come here, in that a class now, I have what we call the serial number of the what of the students. You may have either number 1, number 2, number 3 down the what the line. Then here you are talking about what the age. Here you are talking about what the height. Here you are talking about the what the weight and the rest of them. The first student stands up, tells you the age, you record say 25. It gives you the what the height. Perhaps you reach either what 27 or whatever what meter. Then it tells you what the weight. Perhaps you record 65 kg. You come to the what to the second student. It gives you the age, it gives you the height, it gives you the what the weight down the line. So these are different experimental units standing for the students. These are different subject matters talking about their age, their height, and their what their weight. This is what we call a cross-sectional data. Then when we talk about the time series data, in a time series data, we are talking about a data that is indexed by time. That is a collection of what data based on time parameter. You might be looking at either the price of a particular commodity or the quantity of a particular commodity sold in a particular shop. So you are going to come to that shop in day 1, and then they will now tell you the number of the cartons that they have sold for that day. You record, you go. The next day you return, you ask them how many number they sold of that particular subject, which is either the particular carton of the particular product they sold, you equally record. So all these particular observation you are dropping each day is indexed by time. The one collected yesterday, the one to collect today, and the one to collect tomorrow. We call such a time series what data. It is always, emphasis here is always on a particular subject matter. It could be on the quantity, it could be on what? On the price. For instance, I can give illustration of about that time series data this way. You can have something like time series data existing this way. Then you can come here and have what we call, you draw a line here. Here I might be talking about either in days, in years, or in hours. So I can call here my days. Then I now talk about what? Number of cartons sold. Number of cartons sold. On day 1, you come to that place. You ask them, how many cartons did you sell? They might tell you 30. Then in day 2 you come, they might tell you 27. On day 3 you come, they might tell you what? 40. Down to the number of the days that you want to collect that observation. We call this kind of a thing a time series data. But when we come to panel data, we are talking about a data that combines the attributes of a cross-sectional data and equally a time series data. Reason being that it is a collection of observations or measurements from many experimental units on a different subject matter that is repeated over time. That's why they normally say that a repeated measurement of observation occur in a panel data. You understand? So you come, be it that now you come, for instance, let me give illustration of what we mean by panel data using here. You might come and have something like what we call your serial number, or what we call, yes, your serial number. Then after the serial number, you talk about what? Age. You talk about something like what? Height. You talk about something like what? Weight. Then the observation might be what? 1. That's the number of students in the class might be 1, 2, 3, for instance. Then here it might be happening on January, the month of January. You come in this month of January, you get the age of these students, take their height, take their weights. Either in the month of what? February, you return back. These students are saying 1, 2, 3. You take their age, take their height, and take their what? Their width. So it's a combination of several experimental units being the students on different subject matter, talking about cross-sectional, and a combination of what? Of time parameter, talking about time series data. So this is actually what we call panel data. And panel data contains a whole lot of information. So that is under time dimension. Then under the degree of aggregation, we say we are going to talk about what we call the micro data and then the macro data. So permit me to clean here. I'm done with the time series. So we talk about what we call the micro data and then the macro data. When we're talking about the micro data, we are talking about data collected from a unit of a production, be it company A or firm A or firm C and the rest of them. Observation taken from these individual firms or units of production is actually constituting what we call micro data. But when we're talking about macro data, we're talking about aggregate of this production, collection of the aggregate of this production. That is, of course, why this macro data is often regarded as data coming from maybe the gross domestic product, GDP of a nation, the what we call the per capita income data, and the rest of them. So that's actually what we call micro data and what we call the macro data, coming from the degree of aggregation. The last but not the least is what we call level of measurability. And in the level of measurability, we're talking about qualitative data and what we call quantitative data. Qualitative data refer to those data that cannot be measured, but they can be counted. You cannot measure them, but you can count them. For instance, if you're talking about number of the students who work in a particular class, you don't need to measure the number of students in a particular class. You count the number of students in a particular class. When you talk about number of people in the market, you don't measure it, you count it. Number of items, you don't measure it, you count it. So these are coming under what we call the qualitative data. And one, of course, we talk about even qualitative because this one I described here is more or less of what we call descriptive data. But when we talk about this qualitative, we don't measure it. We use a code to represent it. Like when you talk about qualitative data, somebody is talking about a data taken from maybe male and female. You cannot measure a male, you cannot measure female. Data collected from maybe employed and unemployed. You cannot measure unemployed and measure employed. So these are coming under what we call the qualitative data. But in the quantitative data now, we are talking about data that is measurable. You can measure them. Either the height, you have to measure the height, the weight, you have to measure the weight, and then the rest of them. That's what we talk about the qualitative data. So one can easily ask you, what kind of data is a measurable data and what kind of data is a qualitative data? It is qualitative when it cannot be measured, but it is quantitative when it can be measured. That is under what we call the level of measurability. So we have now looked at small on the types of what data. So we now come down and talk about what we call the sources of data. Sources of what? Of data. So under the sources of data, we have what we call under the source of data, we have what we call the primary source of data and then the secondary source of data. Primary source of data. Primary source or source of what? Data. And then what we call secondary source of data. When is data said to be primary and when is data said to be secondary? A set of data is primary, or a data used for a particular research is said to be what? Primary, if it is collected directly by the researcher. Be it going to lab to conduct an experiment and measuring these values down by himself and using it for a particular research, that data is regarded as a primary data. Or be it going to the field and then asking questions from the respondents and taking down the replies in form of what? Data. That thing is regarded as what we call primary data. But when we talk about secondary source of data, we are talking about the use of data that is already published, be it either in magazine, or be it either in newspaper, be it either on radio or on television. Or it could be data coming from the same lab. But you, who is the researcher, is not the person who conducted that research. Instead, you obtain that data from somebody who had something to do about that particular research. That in which you have is what we call secondary data. You call it what? Secondary data. It is only when they begin to talk about sources of secondary data, that I begin to tell them magazine, newspapers, televisions, radios, and the rest of them. Because it is from all these places that we can extract our secondary data, or we can extract data and use it for our own research, though citing these areas where we extracted this data. So that's what actually we mean by primary source of data and then the secondary source of data. Having talked about what we call source of data, it is equally good that we talk about what we call the method of data collection. Method of data collection. Method of what? Data collection. When we talk about a method of data collection, we are talking about medium that we can access data from our respondents and the rest of them. So, and of course, we can use what we call the interview method. Interview method. We can use what we call observation method. Observation method. We can equally use what we call the mail method. Mail questionnaire method. Questionnaire method. We can equally use what we call projective technique. Projective technique. We can equally use what we call the documentary method. When we talk about interview method, is you approach your target audience and then you interview them based on certain topics. Then you report down your finding in form of what? Of data. So it is also a method of what? Collecting what? Data using an interview. Asking people questions, interviewing them, and reporting down your finding in form of what? Of data. Is what we regard to be interview method. It has its own merit and demerits, actually. Then when we talk about observation, you observe this your target audience or target population. And then you record down your findings as you're observing them in form of what? In form of data or units of observations. That's actually what we call by observational method. It equally has its own merit and demerits. Then when we talk about mail questionnaire, we are talking about then you design a questionnaire on the kind of information you are sourcing from your respondents. Then you send this questionnaire to your target audience and then request them to complete it for you. And when they are completed, they are returned back and then you extract the information in this questionnaire to use. So it is equally a means of collecting data from your respondents. And it equally has its own merit and demerits. Then we have what we call projective method. In the projective method, your target audience, you ask them, they tell stories. Stories of how things happened and the rest of them. And you are quiet now. You are maybe taking down your findings from them as they tell their stories and the rest of them. Then in the documentary, You just go to the data that has been documented on that research area of your interest and then extract the data there and be able to use it. Is also a method. Going to the documentaries. All these things, they have their own merit and their demerits. So these are, of course, what we call the sources of data and the rest of them. And of course, because we have talked about data, talked about sample, talked about population, it is important that we talk about another concept called sampling. Called what? Sampling. It is important we talk about another concept called sampling. Called what? Sampling. Called sampling. There is difference between a sample and sampling. Sample is a subset or a unit or a fraction of the population, while a sampling is a technique, a method of collecting units of this population into a sample which we want to use for a research. That is what we call sampling. A means, a way of collecting units of what population and including them in the sample which we want to use for a particular research. That is what we call sampling. And of course, people normally call what we call sampling techniques. These methods that we are going to use to include these sample population units now into this sampling. It is known generally as what we call sampling. And we have what we call sampling techniques. Sampling techniques. Sampling techniques. When we talk about sampling techniques, it has a two broad classification. And that two broad classification are what we call the probability sampling and non-probability sampling techniques. The probability sampling, probability sampling techniques, and then what we call the non-probability probability sampling techniques. What do we mean when we say probability sampling technique? In the probability sampling technique, each and every unit of the population has a known probability or chance or opportunity of going to be included in the what? In the sample. They have determined known probability, measure of chance of going to be included in the what? In the sample. That's what we call probability sampling technique, or what we call probability sampling. Then for non-probability sampling, of course, the items now in this case, or the units of the population, do not have a known probability of going to be what? Included in what? Into the sample. They don't have a known probability of going to be included in the sample. So that is the difference between probability sampling and non-probability sampling. So they might say a sampling where the chance of the population units going to be included in the sample is known is called what? It is called probability sampling. And of course, another name for this probability sampling is what we call random sampling. It is random sampling. And of course, this one can equally be called non-random sampling. This one can be called random sampling. Random sampling. And then this one can equally be called the non-random sampling. Non-random sampling. Okay? So we are going to take them one after the other. You have known what we call probability sampling. You have known what we call non-probability sampling. This probability sampling can be called random sampling. This non-probability sampling can be called a non-random sampling. Then we take them one after the other. So I am first of all going to look at the probability sampling. Under probability sampling, we are going to look at different kinds of probability sampling. And these different kinds of probability sampling is what we call, number one, we have what we call simple random sampling. Simple random sampling. Then number two, we have what we call systematic sampling. Systematic sampling. Number three, we have what we call the stratified sampling. Stratified sampling. Number four, we have what we call the cluster or multi-stage sampling. Cluster. The cluster or multi-stage sampling. What do we mean when we say simple random sampling as an example of a probability sampling? In a simple random sampling, of course, it is the most often used method of what? Of sampling. And in this simple random sampling, each and every unit of the population has equal, underline that word, has equal chance of going to be included in the what? In the sample. And another peculiarity here is that the collection of items or units of the population to include in the sample using this simple random sampling involves the use of what we call random number tables or what we call random generation numbers. So anything that has to do with that kind, we use it now to select the units of this population now into the what? Into the sample. And we now see it is under simple random sampling. Two things that underline here. The probability of each and every unit of the population has equal chance of going to be included in what? In the sample. Number two, the collection of what of the unit involves using the table of random numbers or anything that has to do with random number generation. That is under simple random sample. It could be what these things we call the lottery method and the rest of them. Where you come for a particular class, then you label the number of the students in what in the class. There might be 20 in number, but your interest is to select something like what? 25 out of 10. Sorry, there might be what? 20 in number, but your interest might be to select 5 from them. You come, you label you number them from 1 to 25. Or 1 to 20, sorry. You put them in what? In either a container. You shuffle the what in the container. You begin to draw. The first one you draw, you open it. You look at the number you have drawn. If it is number 5, you select the number 5 from the students. If it is number 4, you select. You keep drawing that way without replacing it now till you are done with 5 persons which you want to select out of the 20 in number. So in this context now, each and every unit of what of the population has equal chance of going to be selected into the sample, and the medium of the selection of these units involves using a random kind of a trial that involves under simple random sampling. Then in the systematic sampling, here equally, the units of what of the population has a known probability of going to be included in what? In the sample. But here, we are first of all going to collect the units that is going to be included in what? In the sample from intervals. That is, we might come and then permit me to clean this up and illustrate the systematic sampling. We might have something like this, and let me say that this thing stands for the entire population. Entire what? Population. Beginning from 1 and ending, for instance, in what? In 200. I might partition this way: 1, 2, 3. I have here now to be 50, have here to be 100, have here to be 150, and here to be 200. This thing stands for what? For intervals. I'll first of all come to this first interval, and I will use a simple random sampling to choose a number between 1 and 50. That number I choose, let me say, it might be number something like what? 20 that I'm going to pick. Once I pick this number 20 from the first what interval, I am going to say that for every 10 or every 30 observations, I am going to select the 30th one. That is, starting from this first one I've chosen here, I'll count 30, then I will select a sample from there. I will equally count 30, I will select a sample from what there. So the moment the first one is chosen, it appears that almost every other units are what are predetermined. Like here is 20. I will now start from here and say 20, 21, 22. Count 30 here. 30 here on top of this one, I will select that one. I will now count 30 again and select that one down the line. That is actually what we refer to as here as the systematic sampling. For instance, now, let me be specific now. I can say that every, let me say, 50 from this 20, I am going to include it here. If you now check, I'll count from here to here, I'll have what? 70. Because I'll begin from what? From this 20 and count 50. It will land me all up to 70. Then I will equally now count 50 now here to this one. And adding 50 now to this one now will bring me as something as what? 120. So these become the units that I'm going to include in what? In the sample. That's actually what we talk about the systematic sampling. Dividing the sample into intervals from the first interval or any particular interval, using a simple random sampling to take what? A sample, and then every other sample that you are going to collect now will be dependent on that particular one. You set an interval that for every 10-10 observation or for every 20-20 observation, you must be including the 20th one in the sample. That's what we call by systematic. As for the stratified sampling, this sampling method is, of course, very important when the population of interest is heterogeneous. And one tends to classify this heterogeneous population now into different homogeneous classes. And then these different homogeneous classes now is what we refer to as a strata. And a particular group of homogeneous units now is what we call the stratum. So you first of all come, classify the heterogeneous population into different strata, and these different strata are homogeneous in their nature. And then in each of the stratum, you are going to use the simple random sampling to select observations that is going to be included in what? In the sample. That is what we call stratified sampling. Very much important when the population is what is heterogeneous. And you want now to have what we call heterogeneous subunits. Sorry, my light has gone off. Then coming to what we call the cluster sampling. In the cluster sampling, or what we call a multi-stage sampling, look at what we do here now. What we do here is that we are equally going to classify this population into different what? Units. But here we are not going to classify it in such a way that the units become homogeneous. No, we are going to classify it in their heterogeneous nature. Each of the words of the cluster represent the true nature of the population. If the population is heterogeneous, each of the cluster is going to be heterogeneous. If the population is homogeneous, each of the cluster is homogeneous. So, and we do this thing when our population is so sparse out that going to all of them might be a problem. We just now need to divide this population into cluster, and each of the cluster is a true representative of what? Of the population. Then we now use it now to then we now use a simple random sampling now, and then coming over here to this cluster sampling. When you want to make your selection, you are not talking about selecting each of the units of the population. You are talking about selecting a cluster from all the clusters that you have divided. So that is what we call a cluster sampling. Permit me to open my windows now that the light has gone off. I think this is better. The window has been opened and I think we can see a little. So these are what is happening under the probability sampling. Then we now look at what we call the non-probability sampling. Non-probability sampling. Non-probability sampling. Non-probability sampling. In the non-probability sampling, we are going to look at what they call the convenience sampling. Convenience. Convenience sampling. We are going to look at what we call the volunteer sampling. Volunteer. Volunteer sampling. We are equally going to look at what we call the snowball sampling. Sampling. Then perhaps we look at what we call the purposive sampling. Purposive sampling. In the confidence sampling, of course, you include the units of the population into your sample based on confidence. You can just assess them at that particular point in time. And then you recruit them into the sample to get whatever information you want to obtain from them and use for your research. That's what we talk about confidence sampling. And you see, it does not involve anything called a probability. It doesn't involve anything called what? Probability. So when we come to volunteer sampling, in this case now, the researcher do not go for the participants. Instead, some participants volunteer to be used for that particular research. And of course, there is no probability here. They have just volunteered and have decided to go ahead and vote and use them. Therefore, every member in that your target population didn't have equal chance of going to be included because some persons now stood up and came out for every other person in that particular target population. We call it volunteer sampling. Then in the snowball sampling is a situation whereby you are making a research and this research you are trying to make, then you do not actually know your target population very well. Permit me to pause a call that is coming in. You do not know your target population very well. So what do? You might need to locate one person that belong to your target population. Then you ask the person question, the person provides you information, and they're able to link you up to other people who are supposed target population. For instance, you are making a research about what? About smoking. You do not have any published list of these are the number of the people who smoke for you to meet them. But in your street or anywhere, you might have a particular smoker that perhaps you are close to. Then you approach the person, you tell the person you want to make a research about this and the rest of them. Then the person supplies you with the information and equally tell you other people who are smoking that you can approach to go and make the same inquiries. You equally meet them, explain yourself to them, take observations now, and ask them to link you up to the rest of them. You continue that way till you must have recruited enough member as you want to include in your sample. We call them the snowball sampling method, which is under the non-probability method. Then when they talk about the purposive that you are going to use, the researcher decide to use his own, in fact, another name of this purposive sampling is what we call judgmental sampling. Judgmental sampling. So you either call it purposive sampling or you call it judgmental sampling. In this scenario, you look at your target populations, then with some level of what judgment you begin to say, this one will be suitable for my research, you recruit that one. The other one will be suitable for my research, you recruit that one. So they fall under what they call the purposive sampling. So somebody might ask you, either in DJ or any other, one of the following is a non-probability sampling. If this is there, it is the answer. 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 But when they give you something like what I mentioned there about simple random sampling, simple random sampling, then they give you something about systematic sampling, give you something about stratified sampling, and give you something about cluster or multi-stage sampling. And they begin to ask you, one of the following is a probability sampling method. If you see this is an answer, if you see this is an answer, if you see this is an answer, if you see this is an answer. Because all these ones are under probability sampling, while all these are under non-probability sampling. They can equally say, one of the following is false, or one of the following is odd. They will list all these ones, and they will pick one here and put here. That one becomes what? Odd. Or they will list everyone here and pick one here and put here now. That one becomes what? Odd. So these are some of the probability sampling and non-probability sampling. A means and a method of we collecting units of a population to include in our sample. So these are methods of sampling. Permit me to clean. Okay, we have talked about a sampling which being a method of getting the population unit into a sample. Okay, having gotten this population unit into this sample, how do we present this sample? And when now talk about what we call data classification and presentation. Having collected this my data, how do I classify this data? How do I present it? And we talk about data classification and presentation. Data classification and presentation. In the data classification and presentation, we classify data and present data using one of the followings. We have what we call an array. We have what we call tables. We have what we call charts. Then we have what we call graphs. We classify and present our data using any of these followings. Of course, what do we call an array of a data? An array of a data is a data that has been sorted either in ascending or descending orders of their values. That's what we call an array of data. For instance, if you have something like 0, -1, 2, 7, and 3. This is a raw data collected the way they are. But you can present this in array by either sorting this data in ascending or descending order of their values. So if you want to go for ascending, you start from what? From the list. And the list here is -1. So you have -1, comma. Second to the list is what? Is 0, comma. Following it is what? Is 2, comma. Following it is what? Is 3, comma. And then the last is what? 7. This is the least observation. This is the what? The highest observation. So sorting data in order of their magnitudes, either in ascending or descending order of their values, is what we call an array. Then, if you want to use what we call descending, you are going to start from the biggest and end at the what? At the least. And the biggest is 7. So you are going to have 7, 3, 2, 0, -1. This is ascending order of their values. This is descending order of their values. Okay? Then we now come and talk about what table. In table, there are two kinds of table. We have what we call the ungrouped frequency table and then the grouped frequency table. I am going to explain what I mean by ungrouped frequency table and grouped frequency table. In an ungrouped frequency table, you are having something like this for the ungrouped. You might have here to be what? X. And you have here to be F. Then you have here 0, 1, 2, and 3. Then you might have here 3, 2, 4, and then 7. What here we are trying to say with this table is that 0 occurred 3 times, 1 occurred 2 times, 2 occurred 4 times, 3 occurred 7 times. This thing does not appear in a group. It doesn't appear in a group. But it appears in a group when we have something like this. I have something like this. I have something like this. Okay? Then I still have this place to be what? X. I still have here to be what? To be F. But I might have here what to what? 1 to what? To 4. So what I have here is what? 1, 2, 3, 4. Interval of what? Of 4. So which means I'll draw a line here and write what? 5. And I'll say 5, 6, 7, 8. I'll stop at what? At 8. I'll start from what? 9. I'll say 9, 10, 11, 12. I'll stop at what? At 12. So I might have here to be 3. I might have here to be 2. I might have here to be what? To be 4. What I'm saying here is that the number of people who had between 1 and 4 inclusive are 3. The number of people who had between 5 and 8 are what? 2. And the number of people who had between 9 and 12 inclusive are what? Are 4. This one is what we call ungrouped, because this thing does not appear in what? In group. This is what we call grouped, because this thing appears in what? In a group. Are we together? Now, this 1 to 4 here, of course, is what we call the class interval. 1 to 4 is what we call the class interval. 5 to 8, the same class interval. 9 to 12, class interval. So that is actually what we call ungrouped frequency table and grouped frequency table. The charts and then the graphs, we are going to talk more about them when we begin to use examples now to present them. So permit me for us to make a more illustration about the group frequency table before we now enter into measures of central tendency. Okay, the example I gave earlier was when I had something like this. That's the example I gave earlier. Had something like this. I had here to be X, I had here to be F. I had 1 to what? 4. I had 5 to what? 8. And I had 9 to 12, if I can remember. I had here to be either 3, had here to be 2, and had here to be 4. This is called ungrouped frequency table. This 1 to 4, 5 to 8, 9 to 12, we call it what? Class interval. So I can show my class interval, show my class boundary, show my class midpoint, show my what we call the cumulative frequency, and the rest of them. So if you want to present this data this way, you can have this thing to be what? C dot I. C dot I here I mean is what? Class interval. And class interval is 1 to 4, 4 to 5 to 8. So I have 1 to what? To 4. The next one is what? 5 to what? To 8. The next one is 9 to what? To 12. This is what we call the class interval. Then I have the next one, C dot what? B. Let me call it, this C dot B is what we call the class boundary. Class what? Boundary. And class boundary, of course, means subtracting 0.5 from the lower class interval. This is the lower class interval. 1 is the lower class interval. 4 is upper class interval of the first class. This is the lower class interval, upper class interval of the second class. So I will come to this first class. The lower class interval is what? Is 1. I'll subtract 0.5 from it. If you subtract 0.5 from it, you have 0.5 too. You add that 0.5 to the upper class interval. And the upper class interval here is what? 4. If you add in 0.5, it becomes what? 4.5. You come here. Then if you come to this 5, which is the lower class boundary, lower class interval here, you subtract 0.5. If you subtract 0.5 from this 5, you have 4.5. You add it to this 8, it becomes what? 8.5. Here it becomes what? 8.5 to what? 12.5. You draw your line. This is what we call the class boundary. So I have my class interval, I have my class boundary. Here is my lower class interval, here is my upper class interval. Here is my lower class boundary, here is my upper class boundary. So anybody can give you the class intervals and ask you to obtain the class boundary. Class boundary proceeds from the class interval. Then let me now have what we call C dot M. Let me call this my C dot M to be what we call the class mark. Class mark. Or what we call the class midpoint. The class mark or the class midpoint is the lower class interval plus upper class interval divided by 2. That is 1 plus 4 all over 2, which is 5 all over 2, which is 2.5. So here it becomes 2.5. You come here equally. This is what? 5 plus 8. So you have what? 5 plus 8 all over 2, which becomes what? 13 all over 2, which is 7, which is what? 6.5. So you come here and say what? 6.5. And you ask yourself a question. What is it that was added to 2.5 for you to get to 6.5? It was 4. Because that 4 is the size of this class, which we call the class size or width. So you add 4 to here. This thing will equally become 10.5. So this one will be 10.5. This thing is what we call the class midpoint, or what we call the class mark. Then I will now come here, permit me to clean here. Then I will now come here and have what we call C dot. First of all, let me have F, where F stands for my frequencies. My frequency here is what? Here is 3, here is 2, and here is 4. I'll draw my line. I will now write C dot what? F. This C dot F is what we call the cumulative frequency. Cumulative frequency. And then cumulative frequency means addition of the successive word frequency. So here is the first frequency. No one exists above it. So I will write what? 3. Then I'll begin to add. 3 plus 2 is what? 5. 5 plus 4 is what? 9. So this is what we call the frequency. This is what we call the cumulative frequency. This is all about the grouped frequency table. How to go about it as regards the class interval, class boundary, class midpoint, frequency, and cumulative frequency. Thank you very much. So, at this point in time, I think we have had enough background such that when we begin talking about measures of central tendency and dispersion, we equally know what we are confronting. We are either confronting measures of central tendency and dispersion for an array of data, or we are being confronted with measures of central tendency and dispersion for ungrouped frequency table, or we are now confronted by the measure of central tendency for grouped frequency table. So we are going to align them in these 3 categories. Measure of central tendency and dispersion for array of data, measure of central tendency and dispersion for ungrouped frequency table, and measure of central tendency for grouped frequency table. So the 3 things we are going to be looking at is what we call measures of central tendency. Measures of central tendency. And then dispersion. Array of data. Or we are now talking about measures of central tendency. And dispersion. For ungrouped frequency table, ungrouped frequency table. Or we are going to talk about measures of central tendency. And then dispersion. Grouped frequency table. Okay? So in order to manage the size of this video, we just want to have this thing, for you to have this in your mind, that this is actually where we are going to be beginning in our next class, as we go about to know much about measures of central tendency and dispersion, which today led us to going back and beginning from data, method of data collection, statistics, and then the rest of them. So in our next class, we record this class and then we continue with the measures of central tendency and dispersion as it concerns array of data, measures of central tendency and dispersion as it concerns the ungrouped frequency table, and as it concerns the grouped frequency table. Thank you very much for your audience, and thank you very much for still trusting in us. We are still committed to bringing statistics and mathematics to you in a very simplified form. So on that note, we encourage you, follow us in our different social media pages, and then equally subscribe and then view, comment on our YouTube channel. Thank you, and see you in our next class.